The ideal tunneling machine for homogeneous, cohesive soil types, including those under the groundwater level, is represented by the earth pressure balance shield, as the excavated ground is transportable and landfillable without any further treatment. Use of the earth pressure balance shield in pipe jacking for tunnel cross-sections of 1.4 to 4 meters is therefore a particularly feasible and inexpensive solution for installing pipelines underground. The following animation graphics present the advantages of this application. A launch shaft is set up on the site. This can be achieved by means of sheet pile walls, slurry walls, or bore piles. The push rails for the main jacking station are assembled in the tunnel axis. These push rails serve to exactly position and guide the machine and tunneling pipes. A concrete block is cast on the back of the shaft, which transfers the force of the main jacking station to the shaft wall. The launch shaft dimensions are kept as compact as possible, but are dependent on the machine size and project requirements. In the case of sufficiently large shafts, both sections, the tunneling machine and machine pipe, can be fully set up inside the launch shaft. The container with the electrical equipment and hydraulic power unit for the main jacking station is placed beside the launch shaft. The tunneling pipes are stored above ground near the shaft. A startup seal is needed to seal the shaft between the pipe and the ground. Tunneling commences once the tunneling system has been fully connected to the hydraulic and electrical supply, with the TBM tunneling through the lean mixed concrete block in front of the startup seal. The main jacking station then returns to its original position, and the first tunneling pipe is installed. When the main jacking station extends its cylinders, it pushes the entire pipeline and tunneling system forward. The force of the presses is transferred to the rotating cutting wheel, and the cutting tools on the cutting wheel remove the soil from the tunnel face during the tunneling process. Openings in the cutting wheel transport the soil into the excavation chamber, which is completely filled with soil in order to safely support the tunnel face. If necessary, the consistency of the soil can be modified with foam so as to produce an ideal paste-like soil. Operation of the machine is such that the earth and water pressure on the tunnel face and counter pressure of the ground in the chamber are balanced in terms of forces. Adjustment of the advancing speed and conveying rate of the screw conveyor makes it possible to control the balance of forces. As a result, there is no variation in the earth pressure, and the support required at the tunnel face is generated. Earth pressure sensors in the excavation chamber continuously monitor this balance, which is also controlled by the machine operator. All of the tunneling parameters are visualized at the control monitor. A belt conveyor passes the conveyed material into the muck skip. Cable winches in the machine and shaft draw the muck skips through the tunnel. Once the tunneling pipe has been installed, the next stroke starts signaling a new tunneling phase. To minimize pipeline friction in the ground, the outer side of the pipes is lubricated with bentonite. Bentonite lubricating stations for distributing the lubricant are installed consistently at brief intervals. The bentonite is injected into the annular gap between the pipe jacket and the ground and spread over the pipe surface. This ensures that friction is kept substantially down. Intermediate jacking stations are required to ensure that the permissible jacking forces are not exceeded. These comprise a steel jacket with hydraulic cylinders mounted to the circumference and are integrated in the pipeline at regular intervals. The jacking force of the main jacking station only then has an impact up to the first intermediate jacking station. It is pushed together as the main jacks are extended. The main jacking station is then locked in its position and acts as a thrust bearing. Thus, the jacket friction only acts on the part of the pipeline which is momentarily moved. A number of intermediate jacking stations arranged one after the other therefore make long advances possible. Bentonite lubrication and the use of intermediate jacking stations are substantial elements of the pipe jacking method and make long-distance tunneling possible without the need of intermediate shafts. Where straight and short tunneling processes are involved, the Heron Connect UNS navigation system comprising ELS target and laser can be used. The laser beam strikes an electronic target. Any deviations from the route are recorded by the software and indicated to the machine operator. With the help of the control cylinders arranged on the tunneling machine articulation, the machine operator can influence the direction and follow the route with the tunneling system. Heron Connect earth pressure balance shields for pipe jacking are suitable for all homogeneous soils with low water permeability, for safe tunneling jobs without causing settlement. The field of deployment of this technology can be considerably extended to include geologies containing groundwater, for example, by using conditioning agents and compressed air support. Offering full-service tunneling, a global network of subsidiaries and associated companies working in related fields allows us to provide advice and comprehensive services around the world.